Hi, everyone. Today, we are going to see some previous escalation attacks on AWS and a new approach on how to spot them using a tool that we, the security team of Prima Assicurazioni, developed. Actually, this tool is open source and is written in Golang. I am Edoardo Rosa, but you should call me Dodo. And I'm a security engineer at Prima Assicurazioni, and my background is mixed because I've done blue and red teaming on on-premise and on cloud infrastructure. My passions are rugby and the automation of remediation and detection on all environments. Today's agenda is quite long, so please call back your parents at home because you will be late tonight. Joking aside, we'll go through some AWS basic knowledge and then moving forward to performing some previous escalation attacks. And the final part is dedicated on how to detect such previous escalation using automation. You may know AWS, but for some of you that hadn't used it, there is a quick and gentle and brief introduction. Amazon Web Services, AWS, is a comprehensive cloud computing platform that offers a plethora of services that may include software as a service, infrastructure as a service, platform as a service, etc. The most used services are Simple Storage Service, S3, Elastic Cloud Compute, EC2, and Lambda function. S3 is a service used to store objects inside containers. These containers are actually called buckets. And basically, you can store whatever data you want. And here is where you can find juicy stuff during your team engagement or during your penetration test. EC2 is a service that basically allows you to create a virtual machine on cloud. But one of the main differences is that from a classic VM is that you can actually execute this instance with a role associated. What does it mean? It does mean that this role is used to perform other action on AWS, and this is actually required because we are in a cloud environment, so we always need authorization and authentication to the other services. This last concept is very important to keep in mind, especially for our demos, and think of it of something like impersonating a Windows user using Windows token. A Lambda function is just a service that allows you to execute some code when a specified event is triggered. And like EC2, Lambdas can be executed with the permission associated to a role. The most important and critical service on AWS, obviously, is the Identity and Access Management, IAM, because it allows you to centrally manage all permission across AWS and is used to specify who or what can access resources or other services. In the next slides, we'll see the basic structure and relationship between IAM entities that are users, groups, role, policy, and actions. Action is the AWS name for permission, and keep in mind that AWS likes to change name to obvious things. Users, like anything else in AWS, are identified by a name and an ARN. ARN is the Amazon resource name. It actually is a string that identifies uniquely a resource. A user can be a member of one or more groups. For example, the membership is used to logically associate a user to a department or maybe a specific permission set. And like users and any other AWS resources, also groups are identified by name and ARNs. Policy are actually what are used to define what an AWS principal is capable to perform on AWS. And user can receive, for example, a policy through a group membership or directly with a link with a policy. A policy can also be attached to a role, and think of a role of something like similar to a service account. It may be seen like a user, but it's different. It's same, but different. And a policy simply define what action are denied or allowed to that principal. And a policy is composed by a statement, It contains the field effect. This can be allow or deny, and a list of action. On each action is described and written as a service name, operation that can be performed to that service. And at the end, we also have the resource field that actually specify what resources can be targeted by that action. When, for example, the IAM delete role should be used to delete a role in AWS, obviously. But if we have the char star in the resource field, we can delete all role in our AWS account. And more generally, when we are dealing with IAM action, the target can be any of the entities that we saw before, for example, users, group, policy, and other roles. At the same, the action works with other services, for example, S3. And in that case of a service that targets S3 service with the char star, we can actually target all buckets in our AWS. Otherwise, the scope can be restricted to a subset of buckets or a single bucket. When we are dealing with cloud, the attack methodology is basically the same that we are used to when dealing with more classic ecosystem like Active Directory or simply Windows networks. And the initial access can be the same. We can exploit a web vulnerability. We can perform some phishing to get credential, for example, for a VPN, or just lurk for some exposed secret or exposed credential, and so on. What actually changed are the specific techniques that we use to abuse cloud misconfiguration and IAM permission to perform both lateral movement and privilege escalation. Most of the paths to abuse are due to IAM misconfiguration caused by a lack of awareness. And an attacker, for example, may only abuse IAM operation to perform privilege escalation without exploiting any vulnerabilities on the environment. And in AWS, there are some actions that are called shadow admin actions, and Bishop Fox, CyberArk, Rhino Security Labs, and many other security companies have done an excellent job to find and describe such combination. And for example, the most known is the IAM PassRole and SSU run instances. These two actions actually allows an attacker to create an instance, pass a role to the instance, and if the attacker has access to that instance, he may dump the credential. Think of it as something like Mimikatz does when you are logging into a Windows machine. Correctly, Clippy found out that we are talking about IAM PassRole, so we're doing a little deepening into the IAM PassRole action. This action is actually used to define whether a user can attach and assign a role to a service. Let's say, for example, that an administrator needs to set up a service on application on an EC2 instance that should interact with a bucket. The IT guy first creates or find is not visible. Okay. The IT guy first create and find a role one with a low privileged policy that actually allows only the operation that we need to perform on that bucket. He then creates an EC2 instance, and when he finds that role and the EC2 instance is created, he then attach this role to the instance. In that way, the administrator actually created a way to authenticate that instance to the S3 bucket, and with the policy, the application running on the instance can actually perform the required operation. But at the same time, and hence the title of this talk, this action can also be abused by attackers to perform privilege escalation. If an attacker can pass an admin role to a service, he may escalate its privileges. That's why IAM PassRole is one of the most important and critical permission on AWS. Now, finally, let's get into action and see how to actually perform previous escalation. In our demos, we'll target a company called Ultima. And Ultima is moving to the cloud. And in one of their first POC to start creating AWS resources, they started using CloudFormation, that actually is a AWS service for infrastructure as code, and they exposed a web service. This web service simply allows user to upload YAML file that will be ingested by CloudFormation to create new resources and configure them. What we were able to do is to find an SSRF vulnerability that allowed us to perform exploration of the file system of the backend and the internal network, obviously. Now, as an attacker point of view, our target is find the crown jewel of this company. We know that this company is storing all its data on S3 buckets. So let's see what we can do, actually. And from the SSRF, we saw that in the etc passwd file, there is a user called EC2 user. And this is quite interesting because EC2 instances exposes a metadata endpoint called EMDS that actually is used to dump the credential of the attached role, if present, along with that information that actually right now we don't care. If this endpoint is not upgraded to use version 2, we can abuse the SSRF vulnerability to access those role credentials. And if you're curious to see what big vendors are using the MDS v1, there is a link at the bottom of this page, and you can see that it's not quite difficult to see such configuration. Demo. You can see? No. Okay. Now you can see, at first we are going to simply curl the web service, and then we are going to exploit the SSRF, simply calling the localhost itself. Now we'll see the content of the etc passwd, and we see this EC2 user. Now we are going to simply query this MDS endpoint. On the right, you can see this blue circle. And during this demo, we'll see this graph will be populated with the information that we actually discovered during our phases of the attack. And we'll see later what does it mean. At the moment, we are using the SSRF to access the EMDS metadata endpoint, and we can explore this endpoint because it's using a directory listing configuration, so we can manually do whatever we want until we found juicy stuff. For example, we are going to see what if a role is attached to this instance, and actually there is one, and it's called CloudFormation Deployer. And simply performing a get to that file, we can see the access key ID, the secret access key, and the token. These are the AWS credential of the CloudFormation Deployer role. So we simply copy and pass them into our shell using environmental variables to instruct AWS CLI, the official AWS tool, to use them for authentication. Now we simply add impersonated CloudFormation Deployer, and we got a foothold on Ultima environment. Now we're going to simply list what kind of policy are associated to this role. There is only one, and it's called EC2 CloudFormation Deployer policy. And what actually this policy allows is to perform a create stack on CloudFormation, a couple of IAM lists for the policy, are described for all stack in our CloudFormation service. But what actually is interesting is the IAM PassRole. This PassRole is scoped only to the service deployer role. So we can actually create a stack passing only the service deployer role. Now let's see what the service deployer role can do. There is an inline policy called Ultima Custom Deployer Policy that actually allows all operation on Lambdas, on EC2, and a PassRole on all roles which name ends with -runner. -runner because we have this char star here that actually scope the PassRole to all roles which name ends with -runner. But there is a problem. We don't know any role with the -runner string in the name. So what we're going to do is a common technique used on AWS pen testing, and it's actually brute force the name of the roles. And we can do that using AWS key because we are simply calling HTTP API, and if the role does not exist, we got an error, no such entity. We can go ahead, test other names until we get a valid one. This one, Lambda Runner, has an inline policy called Lambda Runner Policy, which gives to this role, speed up, some action to actually publish logs on CloudWatch and manage them. But what is interesting is the list function, because until now we didn't have this action allowed by any of our roles, and we can actually try to impersonate somehow the Lambda Runner role to perform other enumeration, specifically on the Lambda service of AWS. What you're going to do is step back and analyze our graph. Now we got access to this CloudFormation deployer that actually allows us to create CloudFormation stack using this service deployer. This service deployer role allows to create Lambda function using all roles which name ends with -runner, and we discovered one. This one only allows list function. So our target is right now Lambda Runner. What we're going to do? Do you have any ideas? Me neither. What we can do is create a CloudFormation stack that actually instructs AWS to create a Lambda function. This function names, you can do whatever you want. At the moment is demo1 Lambda fun. This Lambda will be executed using Lambda Runner role, and the code that this Lambda will execute is the previous Python script. Is simple enough just to say that it just fetch and print the content of proc self environ file. This file contains the AWS credential of the role attached to the Lambda. But we need also a way to invoke that Lambda and fetch the output. So we are going to create a Lambda function URL. This URL is simply an HTTP URL, which can be invoked by anyone without authentication. But there is another problem. How we can fetch this function URL if we don't have any permission to inspect the Lambda that we are going to create? We simply ask gently CloudFormation to print this function URL on the outputs. And this is a YAML file that we are going to ingest into CloudFormation. The stack name is demo1 privesc, and we are going to pass to this role the service deployer as planned. Now we are going to list those stacks to see if the deployment has completed. There is a stack old, we don't care. Demo1 is our stack that is in progress. We wait for a couple of seconds, and we see that the creation is completed, and on the output we have the function URL that actually we created, and is bound to the Lambda. What we are going simply to do is curl this URL and access to the proc self environ content file. And we see the same token and the same access key that we saw before, just different because they are bound to the Lambda runner role. We load them into our terminal. And now we are Lambda runner. What we can do at the moment, we're going to list all the Lambda function in this AWS account. The first one is called backend Lambda API, which is running with Lambda runner. I don't care about. The second one is backend API temp, which is running with a new role that we didn't know about before, and is temp backend API role runner. So from the previous graph, we simply added a new role that can be abused using the same step that we saw before. And the third Lambda is just simply our Lambda that we created before. The permission for temp backend API role runner actually are administrator access. Administrator access is just the domain admin of AWS. So now our target is dump the credential of temp backend API role runner. I maybe choose an easier name. And now we are Lambda runner, and we can do anything. So we step back and we return to the CloudFormation deployer role, and we need to find a way to exploit all our previous escalation to get a foothold to the administrator role. We simply create another Lambda with this new role. The code of the Lambda is the same as we saw before. Another function rule, another authentication, another output, another CloudFormation stack. And after the deployment, we get another rule that we can curl. And now we have access to the administrator role credential. We load them into our environmental variable, as you may know. And actually, we are admin on AWS. Since our target is listing and access all the content of the buckets, we simply go to list the buckets. There is only one called demo1 flag. We are going to list the content of this bucket. There is only a file called flag.txt. We fetch it, and we just print. So, is it clear what we have performed here? And this is a little recap. And we started with a SSRF from the top right blue circle in the EC2 instance to actually dump the credential of the CloudFormation deployer. We discovered that we were able to create a CloudFormation stack passing a single role that was called service deployer. This role itself allowed us to create a Lambda function passing a role, Lambda runner. This role was simply brute forced. And then we discovered all Lambda in our target AWS account. And this allowed us to discover another role which was admin on AWS. We stepped back from the beginning, create another Lambda to actually dump the credential of our admin role. Then we impersonated him. We got access to the flag and actually to the crown jewel of the company. The actions that we performed were totally not OPSEC, because guard duty, the AWS track detection service, should have triggered at least one critical alert, because we called AWS APIs using a role credential associated to an EC2 instance outside AWS from DP of my home. There are bypasses for such detection, but that's another story, and you may find a little write-up on how to bypass this detection on the link at the bottom of the slide. In the second demo, we learned that Ultima, after the previous incident, obviously, started hardening their system and creating ad hoc deny policy to block non-privileged escalation, such that the shadow admin action that we saw at the beginning of this talk. And they even started using all AWS services like Elastic MapReduce to perform data science. They hired a lot of data scientists, but you, one of the latest hires, are not happy with the company and the job you are doing, so decided to delete all data of Ultima. Why? Why not? So we start this demo as Ultima data scientist role. So now we are authenticated on AWS. We're going to list the policy and the permission attached to our data scientist. We see that we have a CloudFormation stack, a CloudFormation create stack, as we saw before, and a PassRole and a couple of IAM action that are useful to perform enumeration. And we can see that we have an easy win because we have the create stack and a PassRole on all resources on AWS. So this seems an easy win, but let's go ahead with the enumeration. Let's check out the second policy attached to this role. Actually, it's called data scientist. And these two policies are managed by AWS and are not written ad hoc by the security team of the DevOps of Ultima. And we see that we have, again, the create stack action, a couple of enumeration action. We can create, delete Lambda. We can list the Lambdas. Basically, we can do whatever we want on S3 buckets, and we can also delete object on the buckets. So we can actually, at the moment, we can perform privilege escalation and delete all the data. Again, another EC2 run instances, at least the PassRole is scoped to only a subset of roles. But we knew that the Ultima security team created a custom deny policy to block a small subset of privilege escalation. For example, they denied the usage of CloudFormation create stack, update stack, run instances, all the Lambda and update operation, and all S3 delete operation. So now, actually, we don't know what to do. First of all, before starting to think what we can do, I can do this, I can do that, we need a target. So we list all roles in AWS, and we simply search for an admin. And we see that there is this EC2 admin. This EC2 admin actually is not admin of all EC2, but is admin of all the AWS account. So this is our target. But how we can abuse this role for our target, which is delete all data? Maybe we can start abusing the autoscaling service. Autoscaling service is just the AWS service that allows you to scale up and down cluster of EC2 instances. At night, for example, you don't want to pay for 1,000 of EC2 instance for just a single HTTP request. And autoscaling allows us to create instances. So first of all, we need to find a way, we need to find an AMI ID. An AMI ID is the identification number of an image that we can use to start these instances. Second, we need a way to access the instance that we are going to spawn. We simply create a cron tab, which runs on simply bash reverse shell every minute. On the right, you can see, again, the information that we actually got for now. And now we created a launch configuration on autoscaling service, and using the previous AMI ID, we are going to start a T1 micro instance because we are poor, we don't want to spend money. And these instances are going to start up with a touched role EC2 admin. And this is actually just the configuration of the instances that we are going to spawn. The last flag of this command is user data, and we are going to pass to this property our reverse shell script. And user data actually used on EC2 instances to perform bootstrap operation. So actually, we got the access using a reverse shell and a persistence, because in each reboot, the script will be executed, and then the cron will be added, and again, we may have access using the reverse shell. Another information that we need to start our EC2 instances are the subnet, because we need a way to route our traffic from the instance to our command and control. So the VPC or the subnet needs to go out onto the internet. In this environment, we have 3 subnets on the same VPC. They are actually in different availability zone. So we just pick one and hope for the best. Now we are going to create an autoscaling group, and we want to spawn at minimum 1 instance, at maximum 1 instance, so 1 instance. That's easy. With the subnet that we choose randomly before, and we wait simply for a reverse shell that we received. So actually, we should be inside the instance that spawned with the EC2 admin attached. Since we are using cron tab, we can Control-C on the reverse shell and just wait for another execution of cron. And we should be EC2 admin. Now we are EC2 admin. We bypassed all the deny privs that the security team created, and now we can actually list all buckets and delete. And that's it. The disgruntled data scientist actually got access to the buckets and deleted all our company data. What we learn is that we can't only find and block paths to admin privileges or domain admin privileges or administrator access privileges. We need to actually to protect the company crown jewels and backup anything. You may backup on another account, on another S3 bucket, offsite, on paper, on Post-it. You can write each byte one by one on the Post-it and attach them on the wall. Do whatever you want, please do backup. And what is the problem? How we can prevent such attacks? In theory, it's simple. You just apply the least privilege, the privilege principle, you update the system, harden all the things, use all the AWS security services. But following that requirement is not always easy or possible in large and complex environment, because we may have a limited scope, we have a high number of entities, services, resources, or simply a limited capacity of the team to follow and control all changes. So we just give root access to the, no, that's not the scope of this talk. And the review of permission in large and complex ecosystem, it's difficult. It's difficult. For example, the image on the right is just a portion of the Prima AWS organization. Each dot represents a resource. And this is just a portion. 2 reports from the Cloud Security Alliance state that most of the organization do not use any security automation at all. And the main reason is the lack of knowledge and expertise on such fields. More in general, we need to have a global overview of the ecosystem, because knowledge is the key. And a full understanding of the environment from an high level enables companies to establish priorities and fulfill security requirements. And there is this motto that states that attackers think in graph. And for example, Bloodhound, the tools that you may know, to exploit and map Active Directory permission on a graph. Is the king of this idea. But why we can't also protect our environment thinking in graph? And that's why we started creating Nuvola. And Nuvola is an open source and community-driven tool developed by Prima Assicurazioni that aims to perform automatic and manual security analysis on AWS environments using graph and YAML files. Nuvola basically reflects the Bloodhound traits used on Active Directory, but on cloud environments, specifically for AWS. And using graph, it's possible to model AWS resources, creating a digital twin using nodes and edges. And like Bloodhound, Nuvola uses the advantages and principle of the graph theory embedded inside Neo4j to discover and reveal relationship between objects, enabling so engineers to perform analysis, not only security analysis, but analysis, because we have an high-level overview of our infrastructure. And the need of this new tool is due to the lack of interactivity, global overview, and specific feature of the others. But don't get me wrong, don't stop using Principal Mapper, Pacu, Scout Suite, Cartography, because such tools are amazing. And I use it, we use it, you should use it, them. But they not quite filled our gaps. So that's why we started developing Nuvola. Our tool has three main features: dump, assess, and enumerate. The first one is used to dump all service configuration and IAM entities to create a graph from all configuration and relationship. That graph can then maybe used to run queries, assess using YAML files to ease the investigation. The third module, not yet implemented, will be used to enumerate all accessible resources from a low privileged account. And this is basically what the collector or Bloodhound perform on Active Directory. And for example, using Nuvola, we can define a simple YAML file to find all EC2 instances with the MDS v1 enable, the metadata endpoint. And the syntax is easier than the one offered by Cypher, that is the query engine for Neo4j. And this allows even non-hardcore analysts to perform assessment. And furthermore, for example, the community should contribute, and maybe you can, to create new rules. For example, you can try to map all cheese benchmark controls using YAML files, and then automatically ingest them into Nuvola to perform the benchmark and get the results. The main advantage of using graphs, obviously, is not to use YAML file, but is to find paths between two points, from A to B. Like the one that we saw in the first demo, this actually is the output of a search on Nuvola to create a way to display a privilege escalation path. We could have found the privilege escalation path for the demo one using a simple YAML file to query all users or roles with the associated action of IAM, PassRole, and CloudFormation Gray Stack to find a path to our targets. Our targets are for example, the policy administrator access or the action create role. And in the output, you can see that actually the CloudFormation deployer role is printed. So Nuvola detected that this role can be used to gain administrator access. Additionally to automation, you can use Neo4j browser, or in the future, a custom graphical interface. We can manually explore the graph to analyze properties and the relationship manually. And using Cypher is always possible to query specific properties of the nodes or the edges. Basically, you can do whatever you want. Finally, we got to an end. And what we learned is that a high-level overview of our infrastructures may be necessary. And from the beginning of this presentation, we started to map AWS entity and relationship in graph. And then with Nuvola, we found a way to use this knowledge for good. Nuvola is an open source tool, so we invite you to participate and contribute to this newborn tool. You may open pull request, write some code, delete some code, open issue, test the code. You can do whatever you want. but please go check it out. I want to thank you for this talk, and I want to thank you also the Romac staff for this opportunity they gave me.